when it's high up in the sky, ozone is our friend. But when it's down here, it can cause respiratory illnesses leading to death. It can also damage plants. So we'd like to have relatively low ozone levels. Ozone comes from reaction of light and the compounds that come from burning fossil fuels. So we'd like to live in places with relatively low ozone levels. That's the problem today, trying to figure out whether places to the west of the city centre have higher levels of ozone than to the east of the city centre. This is a notional city, so it's not Zurich. What I did was I went to 10 places to the west of the city centre and 10 places to the east of the city centre and measured the ozone levels in gardens there. So we have 20 measurements in total, and I want to compare those 10 measurements from each location and see whether there's a difference between ozone levels. I'm going to hypothesize that there is higher levels in the east and the west because of the prevailing direction that the wind blows in. So the data set I can expect therefore has 20 rows, one for each garden, 10 from the west, 10 from the east. It will have 3 columns. One of those columns will be ozone levels, another column will be whether the garden's in the east or the west, and the final column, the third column, will be a unique garden identifier, so I can always go back and understand which garden the measurement came from. So that's the data set, that's the problem, comparison of ozone levels between 2 locations. Let's go to the computer to get started. Here we are at the computer, and here on the desktop is the data file. I'm just going to get rid of my face so you don't get distracted by it. Now, the first thing to do is open this in a spreadsheet program so we can have a look at it. For example, Excel. If I double click on this, it will open in Excel. That might not work on your computer, so I'm going to show you another way of opening this in Excel. Once we have Excel open, we can go File, Open. It's on the desktop, and here we're not able to click on garden ozone.csv. We have to change it to all files, or we could change it to text files. Oh no, that doesn't work, it has to be all files. Excel can be a little bit fussy at times. Then click Open, and here's the data set. There we go. Let's just make the columns bigger so we can see the names. So the first column, ozone, the second column, garden location, third column, garden ID. There are 21 rows. Because the first row is a header row, that means there's 20 observations, 20 gardens, just as we expect. There are 10 west gardens and 10 east gardens. We can see the values of ozone, these are numbers, and here's the garden ID variable. So everything looks great in Excel. Let's close this. We're not going to save it at all. We mustn't save it. We don't want to change it. So don't save. Open RStudio. RStudio. And now the next thing to do is open a script file and put some text in. My analysis of garden ozone levels. And let's remind ourselves of the question here. Question. Do gardens to the east of the city centre have different ozone levels compared to those west of the centre? Good. So when we come back to this, we can be very clear and easily find out what our question is. The next thing to do, that we always do, is clear R using rm list equals ls. And the next thing, what's the next thing that we do? It's import the data. So, what I suggest you do is have a go at importing the data yourself, and after you do, then I'll show you how I did it. So just pause the video and try import the dataset yourself. So this is how I would import the dataset. I'd use the tool in RStudio, import dataset from a text file. It's on the desktop. It's called gardenozone.csv. Open. I think all this is fine. It's got a header, it's comma separated, the decimals are periods, we can see that just here. There are no quotes in here, there were no NAs, and I'm happy for strings to come in as factors. So strings or words, the words west and east come in as factors. And we can see what it's going to look like when it comes into R. So it looks good. Let's just import. It looks good here. Close that, because the first thing we want to do now is take this code that R's written automatically into the console for us. I'm going to copy that and paste it into the script. So I have that. Import the data. I'm going to change the name of it so it's shorter, my favourite, DD. And now I'm going to do something very important, that's save the script. So I've got the script saved. My ozone level analysis. And I'm saving that on the desktop just for convenience. Perfect. Let's run all of this again just to make sure it works without using import dataset. Perfect. Working from the start. So we never trust R. We're going to check to make sure it's done the import correctly by using strdd, structure of the data. Let's just be very explicit with comments. Check the import worked. Structure. And we can see DD, what has been imported, is a data frame, 20 observations, 3 variables. Good. The first variable is called ozone. It is numeric, and here are some of the numbers. The second variable is called garden.location. It's a factor. It has 2 levels. That W/ is width. 2 levels, east and west. And garden ID is a factor also. It's got 20 levels because we gave each garden a unique identifier. Perfect. Next, look at the data in a graph to answer the question. So we just want a graph, quick, dirty graph that's going to tell us the answer to the question. Let's try and do that in the simplest way we can think of, which is to plot ozone, the response variable, against garden location, with the data set that those variables exist in being DD. So ozone, it comes from ozone here. Garden location comes from garden location here. And DD is the data frame that contains that information, those variables. I'm going to run that. This time I'll press run. Brilliant. A relatively informative graph. Now, some people don't like these types of box and whisker plots because they'd rather see the data points. So we can use a little trick to get the data points. Plot the data points, not a summary of them. And here we just change the garden location variable to be a numeric variable. So if I just run garden location, so I'm highlighting garden location, press run, and it only runs that highlighted code. Oops, that doesn't work. It needs to be $. Running this in isolation, it doesn't know that it exists within DD. So if I do $, it tells R that garden location exists in DD. So if we run that, we get those words, and that's what creates this x-axis here. However, if we do as numeric, it turns those into 2s and 1s. So we get a numeric x-axis. Just going to delete dd $, because when we actually run this, it will be run inside plot with this data equals dd information. And here we get this new plot with actual data points. It's plotting a scatter plot because this is numeric and this is numeric. In this case, R automatically made a box and whisker plot because the response variable, the y variable, was numeric, but the x variable was categorical. Good. So we should be able to answer our question from here. There are some other graphs that we could use, and these exist in a package called Lattice, the Lattice plotting package. We have to load that package into R by doing library lattice. Load the lattice library. It's not loaded when we start R up, but it is on our computer. So all we have to do is library lattice. Then we can make a histogram. We can use the histogram plotting function, which is in Lattice. And to use that, we do tilde ozone. And then we tell it we want it to do a separate histogram for each of the two garden locations. We do that with the bar, the vertical bar, garden location. This is saying, please make a histogram of ozone by, or conditioned upon, garden location. The data is going to be dd. Let's run that. Oh, perfect. That's very nice, colourful, huh? One thing that makes this a bit easier to compare the two gardens is if they're arranged one over the other, on top of each other rather than side by side. And we can do that by doing layout 1, 2. 1 column, 2 rows, please. There we go, perfect. West Gardens, East Gardens. Let's just do one more lattice plot. Just by changing this, we can do a different type of plot, a density plot. And so here we've got the data points, and we've also got this curve, which is some kind of function fitted to the distribution of the data. So now we can compare these two. What I'd like you to do now is decide what you think the answer to the question is, and indicate that in the problem unit that's going to come straight after this video. So let's take a break, and during that break you answer that problem unit question.